Good day, class. We are going to discuss on how to balance a redox reactions. So one of your activity is you balance a reaction which is non-ionic. So that type of reaction, you can balance it through inspection or through trial and error method. Okay? Now, in order for you to balance a redox reaction, the first step is you are going to determine the two half reactions. So it is a redox reaction, of course, it is a reduction, oxidation reaction. So you're going to separate the two reactions. So we call it half reaction. So there will be two half reactions. So the oxidation reaction and the reduction reaction. So before you are going to determine which one is being reduced, which one is being oxidized, of course you must know the oxidation number of the atoms or elements that is involved in the reaction. Okay, so first is you assign first the oxidation number of each element, and we have a rule on that one. And I hope you are already familiarized on how to assign an oxidation number of a certain element. Okay. The first one is we have dichromate. Cr2O7, and it is being charged by -2. So one of the rule is the sum of the oxidation number of the atom that is involved in the ions is equal to its charge. And we know that oxygen, the charge or the oxidation number of oxygen is usually 2, -2, except if it is a peroxide. Okay, so -2, then there are 7 atoms of oxygen. So when you multiply, this becomes -14. Now the question is, what should be the oxidation number of chromium, wherein you have 2 atoms of chromium here, in such a way that once you're going to get the sum of the number of once it is being multiplied, that would be equal to -2. So since that is 2 here, and you have here -14, so this must be, the total must be +12. So that you have +12 minus 14, that would be equal to -2. So if it is +12 divided by 2, so that is +6, or that is +6. So therefore, the oxidation number of chromium here is +6. So you have +6 times 2, that is +12 minus 14, that is equal to the charge. So again, oxidation number of chromium is +6. Oxidation number of oxygen is -2. For nitrous acid, again, this is a compound, so it's neutral. So the sum of the oxidation number of hydrogen, nitrogen, and oxygen will be equal to 0, since it is neutral. It's a compound. So we know that oxygen is again -2, except if it is a peroxide, and hydrogen is usually +1, except if it is a hydride. So you have here -2 times 2, that is -4. You have 1 here, so the sum will be -3. So what should be the oxidation number of nitrogen, such that if you're going to get the sum of the oxidation number, that will be equal to 0. So this must be +3. Okay? Here you have chromium, it is an ion, so it is only an element there, so the oxidation number is just equal to the charge. So therefore, chromium is +3. Your nitrate here, ion, it's -1. And again, you know that oxygen is -2, so -2 times 3, that's -6. So what should be nitrogen, such that the sum of the oxidation number is equal to -1. So this must be +5. Okay? So you have +5 plus -6, that is equal to -1. Then examine on the oxidation number whether it increases or decreases. So you have here chromium, which is +6, chromium on the product side is +3. So here you have chromium +6, you have here +3. So what happened to the oxidation number of chromium? It decreases. So therefore, this is being reduced. Okay. On the other hand, you have here the nitrous acid to nitrate ion. So you have your nitrogen, that's a +3, and the nitrogen on the product side, it's +5. So what happened to the oxidation number of nitrogen? From +3 to +5, it increases. So therefore, this one is being oxidized. Okay? So if you are going to determine which of the two reactants is the oxidizing agent and the reducing agent, the one that is being reduced is the oxidizing agent. The one that is being oxidized is the reducing agent. So therefore, the dichromate here is the oxidizing agent. So take note, oxidizing agent. Because of this one, the other reactant is being oxidized. And the other reactant, the nitrous acid, so this is the reducing agent. Because of this one, the other reactant, which is the dichromate, is being reduced. Okay, so we already have determined which one is being reduced and which one is being oxidized. Then we can write the two-half reaction, the oxidation reaction and the reduction reaction. So what is being oxidized under oxidation reaction? That is the nitrous acid. Okay, we'll just write here the half reaction. So you have here the nitrous acid. So you just put a space. So we have nitrate, -1. And the one that is being reduced, we have the dichromate, Cr2O7, you have -2, and it is being reduced to chromium +3. Okay? Next is you balance the elements, all elements except oxygen and hydrogen. Okay. Now, so you have your hydrogen, nitrogen, oxygen. The other one you have nitrogen and oxygen. So which is not oxygen and hydrogen, it's only nitrogen. So you're going to balance nitrogen. So you have your 1 nitrogen, you have also 1, so it's already balanced. No need for you to write a coefficient beside nitrous and beside nitrate. On the reduction reaction, you have 2 chromium, you have only 1, you have oxygen here, no oxygen on the other side, so we have to balance chromium. So in order to balance chromium, we are going to write 2 as a coefficient for chromium +3. So we have already balanced other elements except hydrogen and oxygen. Next is we balance oxygen by adding water molecule. Take note, it should be in sequence which one to balance first. Okay? So once you have identified the two-half reaction, then you balance first elements other than hydrogen and oxygen. Once done, then you balance oxygen. It should be in order. Okay? Balance first oxygen by adding a water molecule. So you have here 2 atoms of oxygen. You have 3 here. So in order to balance the oxygen, you will add water on the other side of the equation. So you will add here water. Only 1 mole of water, since what is lacking is only 1 mole. You have 2, you have 3. So in order to balance, you add 1 more oxygen by adding water molecule. On this side, reduction, you have 7 atoms of oxygen. So we will add here 7 moles of water in order to balance the oxygen. Once done, next that you're going to balance is the hydrogen by adding hydrogen ion. Okay? Balance first oxygen by adding water. Then you balance hydrogen by adding hydrogen ion. So how many hydrogen here? You have 1 plus 2, 3. So therefore, we are going to add 3 hydrogen ion on the other side of the equation. Here we have 14 hydrogen. So we will add here 14 hydrogen ion. Okay? Once you're done with that one, so you have balanced the oxygen, you have balanced the hydrogen. Next, the next thing that you're going to balance is the charges. So under oxidation reaction in the reactant side, it's all neutral, so no charge. On the product side, you have here -1 and you have +1, then 3 atoms of hydrogen. Okay? So in order to balance, so the total here, the total charge here is, you have +3, -1, so the total is +2. Okay? The total is +2. +2. So in order to balance the charge, since you have your 0 charge, it should be on the other side, should be also 0 charge. So since the sum here is you have +3, -1, so the total is +2. So in order to balance, you will add electrons. Electrons, take note, electrons is negatively charged. So the sum here is positive. So in order to have a sum of 0, since on the other side is 0 charge, so you will add 2 electrons. Okay, and just erase this one. Under reduction reaction, so you have here -2 times 1, so you have -2, 14 times 1, so you have 14. So the total on the reactant side, the total charge is +12. Okay, because this is 14, then -2, +12. On the other side, we have 2 times +3, so the sum here is +6. They must have, the two sides of the equation must have the same charge. So, what side of the equation now that we are going to add electrons? In such a way that they will have the same charge. Take note, electrons is negatively charged. This one has a bigger positive charge. This one has a lower positive charge. So therefore, you are going to add electrons on the positive side. Which one with the higher positive sign? So to make it +6, we will add how many electrons? We will add 6 electrons. Okay? So you have +12, -6. So the sum is +6, which is the same on the other side of the equation. Okay? Now you will add only electrons on one side of the equation. Mostly, thumb rule, the electrons is usually added to where hydrogen ion is found. So if you have noticed here, you have here the hydrogen ion, so you add the electrons here. You have here the hydrogen ion, you add the electrons here. Okay, it's a thumb rule. Next is, once you have balanced the electrons, next thing that you're going to do is the number of electrons in the two half reaction must be the same. Okay? Under oxidation reaction, electrons is you have 2 electrons. Under reduction reaction, 6 electrons. They must have the same number of electrons. So in order to do that, you're going to multiply either of the two half reaction or both reactions will be multiplied by a certain number in such a way that the two will have the same number of electrons. Since this one is 6, this one is 2, so you can multiply this one by 3 to make it 6 because this one already is 6. So, what you're going to do is multiply the whole equation by, to make it 6 equal to this one, multiply it by 3. So, since you multiply electrons by 3, everything will be multiplied by 3. Since they already have the same electrons, then this half reaction will not be multiplied by any number. Because our purpose here is the two equations, the two half reactions must have the same number of electrons. I'll just rewrite it here. So this becomes 3 nitrous acid plus 3 moles of water. Then the product is you have 3 moles of NO3, that's -1, plus 3 hydrogen ion, plus, this one is 3 times 3, 9. Can we check? 1, 3, 3, 9, then 6 electrons. Okay? This one, you have multiplied nothing, multiplied it by 1, so I'll just copy it. So you'll have dichromate, -2, plus 14 hydrogen ion, plus 6 electrons. Then you have 2 chromium, this is chromium, plus 3. Then you have 7 moles of water. Okay. Next thing you're going to do is you're going to get the net equation. So meaning get the total. So that you will have the net equation would be equivalent to this one. Okay? Then you can cancel out one from the reactant side, one from the product side. Okay, so you have 6 electrons here, 6 electrons in the reaction in the product reactant side, then product side, so you can cancel out this one. So that's the purpose of having the same number of electrons in order for them to cancel out. Next is you just add. If they are the same element or the same compound on the same side, you can add. If one is on the product side, other one on the reactant side, you can subtract. Get the difference. So you will have here, there is no other nitrous acid, so you will have 3 moles of nitrous acid. You will have 1 mole of dichromate. For water, you have 3 moles of water here. On the other side, product side, you have 7 moles of water. So you can reduce them. So everything here will cancel out. This one, 7 becomes, you have 7 minus 3, so it becomes 4 on the product side. So there will be no more water on the reactant side. For the hydrogen ion, you have 14 hydrogen ion in the reactant side. Product side, you have 9, so you can cancel it out. Then 14 here becomes 14 minus 5, that becomes 14 minus 9, that becomes 5. So you will have only 5 hydrogen ion. So on the reactant side, so no more nitrous, okay, no more. On the product side, so we'll have 3 nitrate ion, and we have 2 chromium ion, and we have 4 moles of water. So the equation now is balanced, but before you're going to conclude that it's already balanced, you have to check it out first in terms of the number of atoms of the elements and in terms of the charges. So if you're going to count here, for hydrogen you have 3 plus 5, 8. There must be also 8 on the other side. 4 times 2, 8, balance. For nitrogen, you have 1 times 3, 3. On the other side should be also 3. So you have 3. Chromium, you have 2. The other side, 2. Oxygen, you have 2 plus 7, 9. On the other side, you must have also, no, it's 2 times 3, 6. 6 times 6 plus 7, that's 13. On the other side, you have 3 times 3, 9, plus 1 times 4, 4. So 4 plus 9, 13, balance. In terms of charges, you have here 1 positive charge, 5 positive charge, so total of 6 positive charge. Here, you have negative 1, times 3, that's a negative 3. Then you have 6, you have positive 3. Okay? It's not balanced because we write it wrong. This must be, that's the purpose of checking. So it's not positive but it's negative 2. Okay? That's the purpose of checking. So this one is incorrectly written. So dichromate is negative 2. Again, you have positive 5 minus 2, so you have positive 3. Here you have negative 3, you have positive 6, so the sum is positive 3. So the charge now is balanced. So it's better to check. So this is now the balance equation redox reaction under acidic solution. Take note, under acidic solution. Why it is acidic? Because you will be able to conclude that it's acidic because one of the product here or reactant is a hydrogen ion. Take note that acids are compounds that will ionize in water to produce hydrogen ion. Okay? Now, if you are going to balance it under alkaline or basic solution, so once you have here, the step is the same up to balancing under acidic solution, and you can balance it under basic solution. How to do it? You will just add OH or hydroxyl ion on the side where the hydrogen ion is found. So we will just continue this one and balance it using the basic solution. Okay? So I'll just continue. I'll use the other color. So we're going to balance this one under basic solution. So you can rewrite everything because when you balance under basic solution, the first step is you balance it first under acidic solution. So if you're going to balance it under basic solution, there will be one more steps that you are going to add, and that is by adding OH ion where the hydrogen ion is found to make it water. You are going to make it, reduce it into water. So I will just rewrite this one. You will have 3 nitrous acid plus Cr2O7 negative 2 plus 5 hydrogen ion. So since you are going to balance it under basic solution and it is where the hydrogen ion is found, you are going to add OH ion the same amount with I'll make it bigger. The same amount with the hydrogen ion. So if you have hydrogen and OH, these two becomes water. Okay? Now since you are adding OH in one side of the equation so that there will be no change, you add also OH on the other side of the equation. Just rewrite, you have 3 NO3 negative 1 plus 2 chromium plus 3 plus 4 water. And you add also OH ion so that there will be no change. Okay? Now this one becomes water. That one becomes water. So we can rewrite it. So we'll have 3HNO2 plus Cr2O7 negative 2 plus this becomes water, 5 moles of water. And here you have 3HNO3 negative 1 plus 2 chromium plus 3 plus 4 water plus 5 OH. Okay? Take note that you have 5 moles of water here, 4 moles of water. So you can reduce them. And we'll have the net equation now, the final equation. I'm going to write it where? So I'll just continue here on top. Okay, continue here. So this one you will just get the difference because one is in the reactant side, one is the product side. So this is 4, this is 5. So everything here will be cancelled out. What remains is you will have 1 mole of water. So the final answer now is you have 3 moles of nitrous acid and chromium dichromate Cr2O7 -2, and you will have only a molecule of water and 3 moles of nitrate. Sorry for this one, class. There is no H. There is no H. Okay. Plus 2 chromium plus 3. So there will be no more water plus OH. How many OH? 5. Plus 5 OH. This must be properly written so that OH -1. Okay. So this is now the balance equation redox reaction under basic solution. You will know that it's a basic solution because one of the substance here is OH. Okay, one of the substance is OH. It is acidic because one of the substance is hydrogen. If in the equation there is no hydrogen ion nor OH ion, then it is said to be neutral. Okay? So this is how you're going to balance redox reaction or ionic equation. So we're going to summarize the steps. So first is, if you're given an ionic equation here, first thing you're going to do is determine which one is being reduced, which one is being oxidized, in order for you to get the 2-half reaction. And how to do it? Assign oxidation numbers. Okay? Then identify which one undergoes oxidation reaction, which one undergoes reduction reaction. After that, you balance all elements except oxygen and hydrogen. Once done, then you balance oxygen first by adding water molecule on the other side of the equation. Next is you balance the hydrogen by adding hydrogen ion on the opposite side of the equation. Once done, you balance the charge by adding electrons. Take note, electrons is negatively charged. So usually electrons is usually added to where the hydrogen ion is found. So once you have that one, you get the net equation. But before you get the net equation, see to it that your number of electrons on the 2-half reactions are the same. If they are not the same, you have to find ways that they must be of equal number of electrons by multiplying a certain number on either of the 2 equations or both half reaction. Once you have that one, then get the net equation. So one of your, at that instant, one of your substance in the net equation is hydrogen ion that is under acidic reaction. If you are going to balance it in a basic solution, then you are going to add OH, same amount of hydrogen ion that is found in your net equation, because you are going to combine the two to make it water. So once you add OH in one side of the equation, you add also OH on the other side of the equation. Then get the net equation. If there is water there in the other side of the equation, then you can get the sum by subtracting the two. Okay, so you will know it's a basic solution because one of the substance is OH. You will know that it is acidic solution because one of the substance is hydrogen ion. That is how you're going to balance a redox reaction or ionic equation. Okay?